Um, Hello everyone. My name is Aleksei, and today I'm going to tell you about how to make generators from Scala check composable using Monaco library and optics from it. First of all, here is a QR code with the link on all materials for this talk. It includes Scala project, this presentation, and a small article about this topic. So today I have only 20 minutes, so I won't be able to get into the details of the Scala check on Monaco. So if you're interested, please check it. Everything works there. So yeah, and let's go further. So what we're going to do today. So first of all, we will define a problem that we want to solve. Then we check our libraries that we're going to use. And we'll see how these libraries can help us with dealing this problem. Okay, so what is our problem today? Let's imagine that we are Scala developers in the world of Westeros. It's an imaginary world from famous TV show and book series Game of Thrones. And we want to develop a service for mobile banking in this world. And in the real world, this imaginary world has lots of regulations in regard of money, and as well as security concerns. So our validation logic will have lots and lots of corner cases, and we want to check this validation logic and these corner cases using property-based tests. So let's imagine that, so there are lots of regions in this world, and each region has its own regulations for banks. And let's imagine that we have 4 regions that we're interested in, like Westerlands, which forbid personal bank accounts for fiat and cryptocurrencies. Crownlands allows using cryptocurrencies only for business and doesn't allow for personal use. No cryptocurrencies are legal in Stormlands, and only 3 cities have no regulations for banks whatsoever. So yeah, pretty much standard rules of some kind in regard of accounting. So let's start with, first of all, with defining of our domain in Scala. It's pretty simple. For that case, we have an account. This account has some kind of account type, billing address, and balance. Address is a country, one of 4 that we checked on the previous slide, and city. Balance is a monetary value assigned to a currency, which can be either a coin like gold, silver coins, or cryptocurrency. Pretty simple so far. Now we want to implement our those validation rules in Scala. So yeah, we just getting input information about account type, billing address, and balance, and then check if everything is okay. And if it's not, then we return an error. So we return a left of validation error in case if there are some problems with validation, or right of account if everything is okay. So in regard of tech stack, today we're gonna use Scala 3 because it is the latest and greatest version of Scala, but in general, this approach should work for Scala 2 as well. Scala check, this is a library for property-based tests, and the interesting thing today here is this gen of t. It's a generator that randomly creates a value of t that is used for in test logic. Then the second library is Monocle for accessing and transforming immutable structures. And there are lots of different stuff. There are lots of optics, but today we are interested in lens and optional. So let's check one corner case from those validation rules. In this case, so we just interested that cryptocurrency is forbidden in Stormlands. And for doing that in property-based testing style, we need to write a code like that. So we have this account type, address balance, and any crypto values randomly generated. And then we need to pass them to account make in order to make this test work. And then we need to check the result. Unfortunately, there is a problem. Because input data is randomly generated, we cannot control really what information will be there. So it can be the generated data can lead to some different errors, or maybe it will be valid completely and it will be right of account. But we want to make sure that we are checking exactly validation, that we are checking that cryptocurrency forbidden exactly in Stormlands. And for doing that, we need to patch this generated data a bit. So we explicitly define that we want to have Stormlands as our country and cryptocurrency as our currency for balance. And in this case, everything works okay. But unfortunately, there is a drawback in this approach as well. In case of deeply nested structures, there will be more and more calls of these copy methods, the deeper nesting is. So it's not optimal, and in real case scenarios, there will be lots of such code, lots of boilerplate basically. So how to improve that? And for that, we have Monocle, which actually was designed for that. So first of all, we need to start with defining our optics. In this case, it's lens and optional. In short, lens is an abstraction for getting and setting a value of country inside a value of address. And the same goes for this case. So getting and setting a value of city inside address and so on. More information you can find in the documentation of Monocle. Lots of articles and talks about this library. Yeah, but we need to continue for now. The next step would be to add a bit of DSL that would help us to combine generators and optics together. So this code basically does the next thing. If we have a generator of value A, f of A, and a generator of value B, f of B, then we can generate a value of A, then we can generate a value of B, and then we can put a value of B inside the value of A. And the next function basically does the same, but the B is static value. So having this DSL in our scope, we can rewrite this property-based test this way. We can take a generator, we can take one of our optics, and then we can use this method by from DSL to put this Stormlands value inside every address that is generated by this patched generator, patched address gen. And we can do the same with balance, but in this case, we're replacing the values not by a static value, but by a value that is produced by cryptogen. Then we can use these patched generators and pass them into our property-based test. And then we really don't need to make any copies anymore, because all these copies are encapsulated in these optics. So, and it would work absolutely the same for structure of with any depth of nesting. And the only thing you need is to have these optics defined for those structures. So, but we can do it, we can write this code just a bit shorter if we define our optics as implicits. Basically, these are the same optics as before, but they are redefined as implicit values using this keyword given from Scala 3. Then we need to change our DSL a bit to work with optics as implicits, but the logic basically is the same. If you have a generator of f of a and f of b, we can generate these values and we can put b inside a here and there. And in this case, we can write the code, we can write the test this way. So in this case, we don't really need to define our optics explicitly here, because in this case, the Scala generator has all the information it needs in order to infer types and choose a proper optic from implicits on its own. So just a bit shorter, but nevertheless, I think it's better, even less boilerplate. And basically, this is the idea behind this talk, that we can combine these two libraries with the help of DSL and use them together in order to reduce the amount of code we need to write for such property-based tests when we want to check particular corner cases in our business logic, in our validation logic, or whatsoever. There is potentially there is possible improvements for further work. So it is possible to implement auto-derivation of optics. So we would avoid having this code at all. So we potentially can do it that all optics will be derived automatically during compilation. But unfortunately, there are some complications. Working with macros in Scala 3 is still quite hard, though it's better than in Scala 2. And auto-derivation of optics would require to either have unique types for each field within your structure in order to in order for the compiler to understand which field to use. There will be a problem if there are several fields of the same time. In this case, it would be not that obvious to understand which field to use in an optic. Or it is possible to make some kind of markup for the fields that we want to generate optics for. But nevertheless, it is possible. So yeah, there is, and the last thing that I want to mention is that actually this approach, maybe when we define our optics as implicits, might be So let's say in Monocle, there is in Monocle examples, in Monocle documentation, their optics are used only explicitly. I think they never, there is no example of working with them as implicits. But in other library, TOEFL, I've seen that they have their own optics, and I've seen that they use them as implicits. So I think it's a good point, but nevertheless, it's not clear if it's good or bad. So yeah, and basically that's it from my side for today. Thank you all. Yeah, this is the end.